Hi there, my name is Mark, and this is Pacific Northwest Solar. Our family has a solar array installed at our property in rural western Washington state, on the west coast of the United States. I've been inspired by other YouTubers to share my experience with our solar array and how it impacts my power costs. This video details my results for August of 2024, and I hope it will be useful information if you are considering getting solar at your home. Please also see the link to my separate video that gives more details on our installation, listed below in the description. Here's a picture of our 16 kilowatt ground mount solar array. The solar array is directly south facing in one of our pastures, with no trees or other obstructions around it. We have 50 Z and Shine panels, rated for 320 watts each, with Hoymiles M300 microinverters on the backs of the panels. These microinverters convert the panel's DC output to 240 volt AC power, which is sent back to the breaker panel at the house. There is only one choice of electricity providers where we live. Currently, the cost of electricity from the grid is the same no matter what day or time it's consumed. No time of use rates. Any power generated automatically goes to usage in the house first, and then any additional is automatically returned to the grid. We get a 1-to-1 credit for each kilowatt hour that we send back to the grid. These credits directly deduct from the power we are charged at the end of the month. As you can imagine, the overall idea is to overproduce in the summer and use the credits to reduce or eliminate the electricity bill in late fall and winter months. I am using a Sense device in my electric panel to track power generated and power consumed, and I have written a custom Python program to capture real-time metrics for the entire system that I save and analyze. This is what the Sense app looks like, showing the statistics for the month, including solar production, usage, energy to the grid, and energy from the grid. Solar production was very high, over 2,137 kilowatt hours for the month. The fully blended cost for electricity in this month, including all taxes, fees, credits, would be 12.7 cents per kilowatt hour, which is about 10 pence per kilowatt hour for my UK viewers. Using this rate, the value of the solar production for this month was $272.26. The cost of my usage would have been $178.64 at this blended rate if I didn't have solar. Here's a look at the solar production for August 2024 by day. Total production for the month was 2,137.2 kilowatt hours, with the lowest day being 11.1 kilowatt hours on August 23rd, and the highest being 101.2 kilowatt hours on August 2nd. The overall average production per day was 68.9 kilowatt hours. Looking at past data over the last few years, July is the most optimal month for solar where I live. The total amount of hours of sunlight per day went from 14.8 hours at the start of the month to 13.4 hours at the end of the month. There were some cloudy days in the month, but there were 9 days where production was above 90 kilowatt hours in a day. August was definitely less sunny than July, across the board, and you can see it reflected in the numbers. Here's some additional details for the highest solar production day, August 5, 2024. At my location, the sunrise was at 5:53 a.m. and sunset was at 7:35 p.m. for a total of 14.7 hours of daylight on this day. The highest 1-minute sampled solar production was 12.5 kilowatts at 1:51 p.m. Very impressive production. Sunny nearly all day long. Here is solar production and actual usage, plotted together for the highest solar generation day of the month. The AC was on for 8 hours of the day, which is why the usage doesn't drop below 2K for the majority of the day. Lots of laundry, dishes, and cooking happening during this day, so usage was higher than a typical day. Here is solar production, overall usage, energy sent to the grid, and energy from the grid on a per-day basis for the month, relative to each other. Usage, in this case, is power used by the house, regardless of whether it came from the solar panels or not. The large-to-grid spikes were on days with high solar production. You can see some days of more electricity sent to the grid than from the grid. Here's a comparison of the August 2022, 2023, and 2024 solar production, along with the yearly totals for each year. 2024 has been the best year so far for solar production, slightly more than 2022. As a way of comparison, the PVGIS website suggests that I should get 2,376 kilowatt hours at my location during this month, but I didn't get to that level due to the several very cloudy days in the month. Here is the month-by-month comparison of our usage between 2022, 2023, and 2024, along with the yearly total usage. Cumulative usage for 2024 is significantly lower than 2023 and 2022. by more than 5 megawatt hours. I'm very happy with this overall yearly usage reduction. Here is the month-by-month comparison of the actual amount that I paid the power utility each month for 2022 through 2024. My bill was $7.49 this month, for 5 months in a row, which is the standing charge. My solar generation offsets all my power usage on a per-month basis, and I'm building up credits to be used in the winter. My credit total now is nearly 4,500 kilowatt hours. I believe that September will show that I have generated as much as I used, or slightly more. Here is a graph that shows the lowest and highest recorded temperatures on our farm in Fahrenheit for August 2024. The high temperature of 88 degrees Fahrenheit, 31 degrees Celsius, was about normal for August. Thanks for watching. Please give this video a thumbs up so other people will be able to view this video. If you have any other statistics that you would like to see, please leave a comment down below. Have a great solar day and see you next month.